First thing we need to do is determine the reduction and oxidation half reactions. Oxygen here is -2. 2 times 3 is -6. Therefore, this must be +3. Oops, +3. On this side, we'll assign oxygen -2, so that'll be -8. We'll assign hydrogen +1, so that'll be +3, -8. So AS here must be +5. So what's happening to AS? It went from +3 to +5. That's an increase, therefore that's our oxidation. AS is oxidation, so we'll go ahead and write that here. AS2O3 goes to H3ASO4. Now let's look for our reduction. First we'll check out NO3. If we assign oxygen again a -2, the whole thing needs to total -1, so we've got -6 so far. Therefore N must be +5, so that you add to -1. On this side, if oxygen's -2, N must be +2. So oxygen stays the same, nitrogen goes from +5 to +2, that's reduction. So we'll write that in our reduction slot. NO3 minus goes to NO. Now we're ready to go through the steps. Balance all elements except hydrogen and oxygen. So if we look at this equation, your nitrogen is balanced. We're waiting till later on our oxygen. This equation, we need to balance our AS. We'll wait later on the hydrogen and oxygen. So we have two AS's here. So if we put a 2 here, that balances our AS's. Next step is balance oxygen by adding water molecules. We'll start with our reduction reaction. We have 1 oxygen atom here and 3 over there. So we need to add 2, let's do that in red since that step is written in red. We need to add 2 oxygens, therefore 2 water molecules. That gives us 1, 2, 3 oxygens on the right. We have 3 on the left. Down here, let's see, we have 3 oxygens on this side, and we have 2 times 4 or 8 oxygens on the right. That means we need to add 5 oxygens on this side, so we'll add 5 H2O. Now that balances our oxygens. There's 5, 6, 7, 8. 2 times 4 is 8. We've taken care of that step for both of our oxidation reduction reactions, half reactions. C, balance hydrogen by adding H+. So let's take care of that. For our reduction reaction, we have 4 hydrogens on the right, so we're going to add 4 H+ ions on the left. Let's do the same for our oxidation reaction. We have 10 hydrogens here and 6 there, so we're lacking 4 on this side, so let's add 4 hydrogen ions, and that balances our hydrogens. D, balance the charge by adding electrons. So we need to total the charge on the left and the right. On this reaction we have 4 positives and 1 negative. So on this side we have 0. Therefore, we need to add 3 to this side. If we add 3 electrons to this side, we'll have 4 minus 3 minus 1, 0. That makes that side 0 to equal this side, which is also 0. If we look at the oxidation reaction, we have a total of 0 charge on the left. We have 4 positives on the right. So we need to add 4 negatives to make both sides equal 0. So we've taken care of step D. That brings us to step 3, which says that the number of electrons we add to both sides has to be equal. In this reaction we have 3 electrons added, in this reaction we have 4 electrons added. To make those balance, we can multiply this equation. Let me make this in orange. We multiply this equation by 4, and we multiply this equation, put a 4 there, and multiply this whole entire equation by 3. That'll give us 12 electrons for both. So that's what we'll have to do. So for this one, for the reduction reaction, we'll say 4 times 3 is 12 electrons plus 16 hydrogens plus 4 NO3 minus gives us 4 NO plus 8 H2O. Do the same thing for the oxidation reaction. That will give us 15 H2O plus 3 AS2O3 yields 6 H3 ASO4 plus 12 H plus 12 E. That takes care of that step. Now we need to add the half reactions and cancel identical species. So we will add these two reactions. I'm just going to add everything on the left together and everything on the right together and cancel identical species as I go. I can already see that the 12E on the right and the 12E on the left can go ahead and cancel. So I'll go ahead and total everything else and cancel that when I get it written. So if I add up what's on the left, I'll get 16 hydrogens plus 4 NO3 minus plus 15 H2O plus 3 AS2O3 yields 4 NO plus 8 H2O plus 6 H3 ASO4 plus 12 hydrogens, because we've already canceled our electrons. So let's start with our hydrogens. On this side we have 16 hydrogens. On this side we have 12 hydrogens. So we can cancel the identical ones. So 12 hydrogens will cancel, which will cancel out the 16 here and leave us with 4H. Next we will look at our waters. We have 8 waters on this side and we have 15 on this side. So we can cancel out all 8 of these, and that will leave us with 7 waters on this side. And everything else can be left as is. So we can rewrite this equation to be 4H plus 4NO3 minus plus 7H2O plus 3AS2O3 yields 4NO plus 6H3ASO4. And that is our balanced redox equation.